To read to you a book about electricity. The book is called Wired. It's by Anastasia Soon and illustrated by Paul Carrick. Electricity starts with something you cannot see, electrons. Electrons are part of an atom, and atoms are inside everything, including you. Electricity is electrons on the move. To create electricity, we make electrons move on purpose. The electricity that you use every day moves on wires that run all over the city. But one electron does not travel from a power plant straight to your house. Oh no! When electrons move, they dance in circles. As the electrons dance, electricity flows from one electron to another. The electrons dance the electricity from the power plant all the way to your house. As long as the electrons keep dancing, electricity can keep flowing. At the power plant, machines make power by making electrons move. As water flows through the dam, it makes big wheels called turbines spin. The turbines are connected to a generator. Inside the generator is a large magnet surrounded with wires. When the turbines spin, the magnet spins too. As the magnet spins, the electrons in the wires begin to move. Electricity has been created. And there's the large turbine. Outside the power plant, the wires from the generator connect to a step-up transformer. Inside the transformer, two coils of wire circle around a core. One coil is longer than the other, so it goes around the core more times. The electricity enters the transformer on the smaller coil. This creates a magnetic field, so the electrons on the longer coil start dancing too. Since the longer coil circles the core more times, electricity is stepped up. Stepped up electricity has more voltage. Voltage is like pressure in a hose. The more water you have flowing through the hose at once, the stronger the spray and the higher the pressure. The more electrons you have moving through a wire, the higher the voltage. The three wires coming out of the step-up transformer are called high voltage lines. The high voltage lines from the step-up transformer are carried on tall towers called transmission towers. Transmit means to send. The electrons in these wires dance the electricity from one place to the next. Transmission towers carry high voltage wires for miles and miles. The voltage these lines carry is very high. When electricity comes into the step-up transformer, it is 13,000 to 24,000 volts. After the electricity is stepped up, it can be as high as 345,000 volts. When the high voltage wires come near a city, some branch off to a branch station or substation. At the substation, the wires come down to earth and connect to another transformer. The transformer will step down the voltage. A step-down transformer also has two coils of wires around a core. The wires coming in from the high voltage lines connect to the longer coil. As the electrons on the longer coil dance, they create a magnetic field inside the transformer. This makes the electrons in the smaller coil start dancing too. The smaller coil has fewer turns around the core, so the voltage or pressure has been stepped down. Now it's time to feed the hungry city. Distribution lines or feeder lines reach out all across the city. These lines distribute power to everyone in the city that needs it. Feeder lines carry electricity to your neighborhood, but this voltage is too high for you to use at home. All over the city are distribution transformers, small step-down transformers. With their coils, these transformers change the high voltage into medium voltage. The lines at the top of the pole carry the higher voltage. These lines are called primary lines. After the electricity is stepped down again by the distribution transformers, it goes to the secondary lines. Now it is ready to go to your home. The secondary lines reach each building in the city at a service head. Wires from the power company connect to wires from your house. These wires don't carry 345,000 or 24,000 or 13,000 volts anymore. They only carry 120 volts, just right for your house. But that's still dangerous voltage, so don't touch. The wires travel down a conduit to the electric meter. The meter measures how much electricity travels to each building. Below the meter is a grounding rod. Believe it or not, the dirt in the ground is a safety feature. Too much electricity flowing in the wires can cause a fire. To prevent this, a copper wire is attached to a rod in the ground. If too much power flows in the wires, the grounding wire carries the extra power to the rod and into the ground. Three wires travel through the electric meter to the service entrance. Two wires are hot wires and one is neutral. After you use the electricity, the electrons keep dancing, only now they dance out of your house on the neutral wire. The path electricity makes as it travels from beginning to end and then back again is called a circuit. The next stop for the dancing electrons is inside your house. The two hot wires, the neutral wire and the grounding wire, go through the wall to the service panel. Here the wires reach the main breaker. A breaker is a switch that can stop the power. If something goes wrong with electricity, the breaker pops and breaks the circuit. It makes a gap so the wires no longer touch. When that happens, the power stops flowing. The main breaker can turn all the power for your house on or off. The electrician who puts the wires inside the walls of your house didn't make one long path or circuit for the whole house. Oh no, he created many, many paths. Each one has a breaker in the service panel. The labels on the panel door tell you where the circuits travel. The wires inside the walls of your house are bundled together in cables. Most cables hold three wires, a hot wire, a neutral wire, and a grounding wire. Two hot wires come into your house, but only a few of the appliances you use, such as your washing machine, need all that power to work. Most appliances can get enough power from only one of the hot wires. The tight plastic covering of the cable holds the wires together. One end of the cable is connected to the service panel. Each cable travels through the wall until it reaches a box. Inside the hollow box, the three wires from the cable are connected to switches or outlets. Switches connect power from the service panel to an appliance, like a light on your ceiling. To make a switch work, the electrician connects a hot wire from the cables on each side of the box to the two screws on the far side of the switch. The neutral wires are twisted together in a wire nut. The wire nut keeps the wires touching so the electricity can keep flowing back through the circuit. The grounding wires from the two cables are connected by a wire nut. A third grounding wire extends from the wire nut to a screw on the near side of the switch. This grounds the switch. When you flip the switch on, it closes the gap between the wires inside the switch. The electricity moves from one wire to the next and then power flows. When you flip the switch off, it makes a gap so the wires are no longer touching and the electricity stops. Some wires are connected to an outlet. These wires wait for another connection from a plug. Plugs and cords have wires inside. When you put the plug into an outlet, electricity travels through the wires in the plug and cord. Some things turn on as soon as you plug them in. Others have an on switch you must flip to close the gap and complete the circuit. Electricity is always on the move. As electrons dance in circles, they move electricity from the power plant to your house and back. As long as the electrons keep dancing through the wires, electricity keeps flowing. I hope you enjoyed our book today, Wired. It takes a lot of different things happening to make electricity, so just remember about our book when you turn on a light inside your homes. So we'll see you soon.